Welcome back, Logan, to another installment of Math from Your Couch. Hopefully you had a good Cinco de Mayo and a great May the 4th. Today we're going to continue where we left off on the last video, which is talking about angles and their relationship to the arcs that they intercept. The angles today are the ones that look like the orange, yellow, and red angle. You'll notice that all three of these angles occur outside of the circle. So today we're going to be talking about angles that occur outside of the circle. In addition to having those angles outside the circle, you'll also notice that they all have two arcs inside their angles, two arcs inside their angles. The first arc that we're going to talk about, I'm going to call the arc that bends towards the angle. These arcs bend towards the angle. So the purple arcs that I've highlighted bend towards the angle. Now these green arcs here, these green arcs bend away from the angle. And I'll refer to those as bending towards the angle or bending away from the angle. Now, there is an equation that you can use when talking about these things. The relationship here is that the angle, right, so the things I circled, is equal to the arc that bends away from the angle minus the arc that bends towards the angle divided by 2. To give you a better understanding, let's color code that a little bit. So the first thing is the angle. We're talking about the orange, the yellow, the red, the things that I circled. That right there, that angle is equal to the green arc, right? So it's the arc that's bending away from the circle, the larger arc, minus the smaller arc, or the arc that bends towards the angle, divided by 2. And this is the equation we're going to continue to use on all of these types of problems. All right, so let's take a look at an example. Our first example, example number 1, looks like this. So we have two secants. That means two lines that intersect the circle in exactly 2 locations, and they intersect outside of the circle. So the 2 lines intersect outside of the circle, and we have an arc right here that bends away from my angle, and we have an arc right here which bends towards my angle. So the equation is that the angle is equal to the arc that bends away, right? So bends away minus the arc that bends towards divided by 2. So we're just going to plug it in, all right? So we're going to plug in. So my angle, which is 30 degrees, we have 30 degrees, is equal to the arc that's bending away from the angle is up here, the 70. So we have 70 minus the arc that is bending towards my angle, which is the x, divided by 2. And now we're just going to cross multiply and solve this thing. So we're going to divide this by 1 so that we have 2 fractions, and now we multiply 30 times 2, which comes out to 60. So 30 times 2 is equal to the 70 minus x times 1. So we have 60 is equal to 70 minus x. Subtract the 70 from both sides, and we get negative 10 is equal to negative x, and divide both sides by negative 1. And we have x is equal to 10. So this is a 10-degree angle here. All right, let's take a look at our second example. Second example, very similar, except this time we have a tangent and a secant. The tangent is the one that intersects the circle in exactly 1 location, and the secant is the segment that intersects the circle in 2 locations. All right, so this one over here, we have our arc that bends away from the circle, and we have our arc that bends towards the circle right here. So our equation is that the angle is equal to the arc that bends away from the circle, which is 180, minus, this guy, the guy that we don't know. So we don't know what this is. We need to figure that out. So anytime you get stuck on a problem like this, or anytime you get stuck in the math problem, you sometimes will have a new question. And the question is what is this thing? So I got to figure out what this arc is. If I can't figure out this arc, then I can't do the problem. So let's take a look at more information. Well, I have this arc here, which is 60. Now, the fact that they gave me that was not is important, because if I look, I have arc 1, arc 2, and arc 3, and all 3 of those arcs make the full circle. So I can just say that question mark, that thing I don't know, if I add it to 180 and I add it to the 60, that should be the whole circle, which is 360. So we're going to solve for that question mark right there. The 180 and the 260 comes out to 240, and if I subtract the 240 from 360, I get 120. So we're going to subtract the 240 from both sides, and we get 120. So that tells me that this question mark is 120. So now the arc that bends towards my angle, I now know is 120. So I'll put a 120 in there, and we divide by 2. All right, this one here, since the x is already by itself, we don't actually need to cross multiply. We can just simplify. X equals 180 minus 120 is 60, and 60 divided by 2 is 30. And there's our second example. All right, moving on to example number 3. Example 3, we've got 2 tangent lines this time, and they intersect to form that 70-degree right angle right there. And we have our arc that bends away from our angle, and then we have our arc that bends towards our angle. This time, we don't know what this is, but you'll notice that there are 2 arcs total. So here's the technique. On these types of problems where you have the tangents, sometimes it's important to understand what this is here. If this is x, then this right here needs to be 360 minus x. So this whole piece here is 360 minus x. And the reason is because if the whole thing is 360 and I have x, if I took it away from the 360, that would give me this. Let's try an example. If this was 50, then this right here would be 360 minus 50. If this was 100, then this would be 360 minus 100. Now, since I don't actually have a value for it, I just have x, then I can write it as 360 minus x. And now we can set up our equation. The angle is equal to the arc that bends away from the angle, 360 minus x, minus the arc that bends towards my angle, the x, all divided by 2. Now, since the variable is not isolated, I am going to make the 70 over 1 a fraction. And I'm also going to collect like terms right here, those negative x's. So this gives us 70 over 1 equals 360 minus 2x over 2. We'll go ahead and cross multiply. That gives us 140 from multiplying the 70 and the 2. And 1 times 360 minus 2x is just 360 minus 2x. At this stage, you can just solve the problem by subtracting the 360 from both sides. And this gives us negative 220 equals negative 2x. Dividing both sides by negative 2 results in 110 as x. And we now know that this angle is 110. And if you subtract 360 and 110, you'll come out with 250, which is important because if you add the 250 and the 110, that comes out to the full circle of 360 degrees. This, in my opinion, is probably one of the harder problems, and just remembering this technique right here for these tangent type problems is going to be really helpful. All right, our last example. Now, in our last example, you'll notice that there's less angles and less values, numbers, and there's a lot more variables. But the problems still approach the same exact way. We have an angle, we have an arc that bends away from our angle, and we have an arc that bends towards our angle. So we set up our equation. The angle, which happens to be 5x minus 3, is equal to the arc that bends away from our circle, so 110, minus, and this is important, it's not just the 2x we're subtracting, we're going to subtract the whole thing. So it's the entire arc that bends towards our angle that we're going to subtract. So we're going to go 2x plus 8, but in parentheses, divided by 2. And on this one, you're going to want to make sure you remember to distribute that negative sign, that minus sign. So we have 110 minus 2x minus 8 over 2. And if you want to simplify that, you can. That negative 8 and the 110 comes out to 102. So we have 102 minus 2x over 2 is equal to 5x minus 3. Now, since the variable is not isolated, I'm going to go ahead and set up as 2 fractions. So I'm going to put a 1 underneath it, and we'll cross multiply. Now, when I multiply the 2 and the 5x minus 3, I get 2 times 5x minus 3 in parentheses is equal to 102 minus 2x. Over here, we're going to distribute. This gives us 10x minus 6 is equal to 102 minus 2x. Now, anytime you have multiple variables, you're going to want to get them all together. So I'm going to get rid of this negative 2x by adding it, which gives us 12x minus 6 is equal to 102. Now it looks like a linear equation where we just add the 6 to both sides, and we get 12x is equal to 108 and we'll divide both sides by 12, yielding x equals to 9. So our final answer is that x is to 9. All right. If you have any questions, go ahead and give me an email or hit me up on Google Classroom or stop by virtual office hours. Until then, I'll talk to you next time.